Good morning. Today's topic is on epidemiology, learning outcomes. Define epidemiology, list the aims, principles, and purpose of epidemiology, list the requirements and uses of epidemiology, distinguish between incidence and prevalence, outline important measurement tools, then list important requisites for measurements. Epidemiology. If you divide the word epidemiology into parts, you can get three parts. Like the first part is epi, which means upon. The second part is demo, which means people. Then the last part, logi, which means study. So epidemiology is nothing but upon people study. Yes, it's upon people study. So coming to the definition, epidemiology is a study of the distribution and determinants of health-related states or events in a specified population and the application of this study to the control of health problem. This was given by John M. Last. Here, few things you have to remember like distribution, determinants of specified population. Why you are finding these things like distribution or determinants to control the health problems. So if you remember three things, distribution, determinants among the specified population to control health problem. So when you are memorizing any definition, try to remember the keywords. Epidemiology is the basic science of preventive and social medicine. It has evolved rapidly during the past 3 decades. The modern epidemiology has entered the most exciting phase of its evaluation by identifying the risk factors of chronic diseases, evaluating the treatment modalities and health services. I think you will be knowing what is risk factors. For example, for dental caries, what will be the risk factor? Maybe consumption of sweets, improper brushing, or any debilitating diseases. So you have to identify the risk factors, then only you can give prevention or treatment. So this is the main aim of any epidemiology. So prevention is the main aim, but you have to find out the or identify the risk factors. The current trends of epidemiology, newer offshoots such as cancer epidemiology, neuroepidemiology, genetic epidemiology, occupational epidemiology, or psychosocial epidemiology. Coming to the history, first known epidemiologist is Hippocrates. First to tell, no disease is sent by evils and demons, but is the result of natural causes. Consistent relationship between the habit, physic, weather, and disease. So he is considered as the first person, the first epidemiologist. Founder of epidemiology is Thomas Sydenham. He is an London physician, recognized as a founder of clinical medicine and epidemiology. He emphasized detailed observation of patient and accurate record keeping. That means if you are observing any patient or any population, you have to observe very carefully and you have to record the things accurately. John Snow is the father of epidemiology. He was the one who mapped the cholera cases in East London during cholera epidemic of 1854. Traced source to single well on Broad Street that had been contaminated by sewage is responsible for cholera. Who is an epidemiologist? Any person who researches into occurrence of disease or disability in a group of population is called an epidemiologist. I will repeat, any person who researches into occurrence of disease or disability in groups of population he is called an epidemiologist. Qualification of an epidemiologist, like if you can use your common sense, you can think over it, like what might be the proper qualification of an epidemiologist. First is familiar with the statistical techniques. You should know some of the statistics. Then well grounded in diagnosis of disease, so he must be an medicine background. Then the third is through with like history and observation or clinical observation relating to epidemics. Then good knowledge of bacteriology, immunology and physiology. Then knowledge of principles of preventive medicine. How you can remember this? The best method is like in your first year you will be having anatomy, physiology, biochemistry. So an epidemiologist should know all these three things. Then the second year pathology, you should know all these things. Then your prevention part, that is community. So if he knows the basics with the community and the medicine, so he will be a better epidemiologist. Epidemiologists need to know public health because of the emphasis on disease prevention, clinical medicine because of emphasis on disease classification and diagnosis, pathophysiology because of need to understand basic biological mechanism in disease, statistics because of the need to quantify disease frequency and its relationship to antecedents, social science because of the need to understand the social context which disease occurs in the present. Coming to the aims of epidemiology, to describe distribution and magnitude of health and disease problems in human populations, to identify etiological factors in the pathogenesis of the disease, to provide the data essential to planning, implementation, and evaluation of services for the prevention, control and treatment of diseases, and to the setting up of priorities among those services. So the first aim is to describe distribution and magnitude of health. Then finding the etiological factor. Then after collecting the etiological factor, then it's like collecting the data essential for the planning. So whatever data you have collected, you have to give it to government so that government will plan a better healthcare delivery services. The ultimate aim of epidemiology is to lead to effective action to eliminate or reduce the health problem or its consequences, then to promote the health and well-being of society as a whole. Coming to epidemiological approaches, the first is asking questions like what is the event, what is the magnitude, where did it happen, who are affected, why did it happen. Then you have to compare it, like making the comparison. What can be done to reduce this problem and its consequences? How can it be prevented in future? What action should be taken by the community, by the health services, by other sectors? Where and for whom these activities carried out? What resources are required? How are the activities to be organized? For example, if you take the present scenario of COVID-19, just compare. The first country which affected is China. By the time Malaysia was not affected, and they were telling these diseases is not spreading man to man. Like in the beginning, the China newspaper, including WHO, were telling that this disease is not spreading man to man or human to human. But later, after 1 or 2 weeks, the same WHO people have reported, yes, it will be spreading from one country to another country or from human to human. Don't know to whom to believe. So, but in the epidemiological approach, you have to search what can be done to reduce the problem and its consequences, how it can be prevented, what action should be taken, what resources are required, and what is the plan for the future. The same things if it is reoccur. So this is the important approach. Epidemiological approach versus clinical approach. Coming to epidemiological approach, it's focus on group, but in clinics it's focus on individual. For example, any epidemiologist, if he goes to the area where COVID-19 is affected, then he will focus on the group of people. But in clinics, if the same COVID patient if come to your clinic, you will be focusing on the single person. So epidemiologists will focus on larger group. Total number of cases, distribution, modes of spread. This is the thing which epidemiologist will search. But the same patient, if he comes to clinic, as a clinician, we will check the signs, symptoms, causes, treatment, like that. Then in the epidemiological approach, the most important is pre-pathogenesis period. For example, COVID-19, the pre-pathogenesis period is for 5 days, then starts like the fever will start, then the respiratory attacks, so like that. But whatever, if you want to prevent the disease, you have to know the pre-pathogenesis. If you know, see, most of the time you can prevent the hazardous effect of any disease in the pre-pathogenesis stage. If you treat them with the medication, most probably we can achieve a good prognosis at the pre-pathogenesis period. In the clinical approach, pathogenesis period is most important because when the signs and symptoms are already there, then only patient will come to clinics. So that time you should know pathogenesis period. So the main difference is epidemiologist should know the pre-pathogenesis period. Coming to epidemiological approach or clinical approach, the continuation of the previous slide. In the epidemiological approach, concerned with environment in detail, epidemiologist will study the environment in detail. But in the clinics, concerned with the environment to a limited extent. Epidemiological approach, investigator go to the community in search of suffering person. But in the clinics, patient will come to the clinics. In the epidemiological approach, the subject matter is conceptual, can only be symbolized in the form of tables and graph. For example, the COVID. Yes, in the Penang, there are 35 patients. In the age group of 60 plus, this many patients. Among them, this many males, this many females. So you can give graphs and tables. But in the clinical approach, subject matter is easily pursued by the techniques as clinical lab examination. Like you can check, this is the hemoglobin count, this is the body temperature, this is the respiratory rate. So these are the clinical signs. But in the epidemiology, you can only give the tables and graph of who is affected, which area is affected, geographical location, like that. Come to scope of epidemiology. It is also concerned with the study of general health status of human population in relation to the environment. Modern epidemiology concerns with not only the epidemic diseases but also communicable and non-communicable disease, namely the cancer, heart diseases, mental illness, dental diseases, congenital defects. Knowledge derived from the epidemiological studies is applied not only for the prevention of disease but also promotion of positive health. Recently, epidemiologists have become involved in evaluating the effectiveness and efficiency of health services. Objectives of epidemiology: to collect and analyze all data relating to the roles of agent, host, and environment to effectively describe the complete epidemiological situation. Then, to analyze and describe the occurrence, distribution, and nature of disease according to the variables such as age, gender, occupation, seasonal and secular periodicity of occurrence of places and habits, customs, mode of living, which altogether constitutes social and geographical pathology of disease. To probe into the role of causes at different stages, where disease often are multi-causal and multiphased, to help the administrator to channel their public health policies to serve the various group of population, age, gender, occupation, rural or urban, to meet the felt needs of these groups in society they serve. To help lay down priorities and targets to appraise their action, and finally evaluate periodically to improve their social policy from time to time. Coming to the principles of epidemiology, the first and foremost principle is exact observation. You have to observe very carefully, then only you can guess what is the probability or what is the cause for this kind of any disease. Then the correct interpretation. Correct means accurate, that is free from error. Then the rationale of explanation. For example, cholera. See, you found out that many people are affected. Then you have to find what is the source of this infection or the foci of infection. Then you have to relate, oh, if this is the foci, then what are the symptoms occurs from this. For example, if a person or people are water from the same well are affected, then that is the foci, the well is the foci. After consuming, what all things are happening, like diarrhea, fever, twitching. So that things you have to explain sensibly. Then scientific construction by expert knowledge and technical skill. Oh, this is the cause of this, so we have to provide this kind of treatment. So we will cure this many people in this many days, and isolation or quarantine. So like that you have to plan scientifically. Coming to the branches, there are many branches: general, specific, experimental, field, clinical, global, evaluating, forecasting. All of these things will come under epidemiology only. Strategy of epidemiology. In order to deal with multiple problems, McMahon and Poe summarize the strategies of epidemiology, like descriptive epidemiology, formulation of hypotheses, analytical epidemiology, then experimental epidemiology. Coming to epidemiological triad. Here you can see three things. First is environment, then agent, then host. So epidemiological triad. Triad means three things: environment, agent, host. Coming to agent factor, the disease agent is defined as a substance, living or non-living, or a force tangible or intangible, the excessive presence or relative lack of which may initiate or perpetuate a disease process. For example, dental caries. It may be caused from bacteria. So agent is bacteria. Classification of disease agents like biological agent, nutritive agent, physical agent, chemical agent. For example, biological agent means bacteria. Nutrient agent means many people are suffering from diet insufficiency or malnutrition. So nutrient is an agent for a disease. Then physical agent, like without the proper exercise, people are gaining weight, which leads to diabetes, or like immovability leads to some other diseases. So chemical agent, for example, if you are consuming or inhaling mercury, so you will be knowing what are the adverse effect of mercury, or smoking, carcinogenesis effect. So these are the disease agents. Absence or insufficiency or excess of factor necessary to health, like chemical factors, nutrient factors, lack of part of structure, immunological factors, then social agents. Come to host factors. Demographic characteristics like age, gender, ethnicity. Like whatever the research you are doing, first you will record the demographic details like age, gender, ethnicity, the location, their like in our case history, the first part. Then the biological characteristics like genetic factors, biochemical levels of blood, immunological factors, and physiological function of different organ system of the body. Then comes the social and economical characteristics like socioeconomic status, education, occupation, stress, marital status, living habits, nutrition, etc. So these are intrinsic factors or host factors. Come to environmental factors, these are extrinsic. The previous one, the host factor, are intrinsic. This is the environmental factor. This is extrinsic. Definitions. External or macro environment is defined as all that which is external to the individual human host, living and non-living, and with which he is in constant interaction. Coming to the classification, physical environment, that is the non-living things and the physical factors, example air, water, soil, housing, climate, geography, heat, light, noise, with which man is constant interaction. Biological environment, universe of living things surrounding man, including man himself. Some of them act as a disease-producing agents, reservoirs for infection, intermediate host, and vectors of disease. Psychosocial environment is defined as those factors affecting a personal health, care, and community well-being that stem from psychological makeup of individual and structure and function of social groups. They include cultural values, customs, habits, belief, attitude, morals, religion, education, lifestyle, community life, health services, social and political organization. Also part of social environment is the people. Components of epidemiology. The first one is disease frequency. Frequency of disease, disability or death summarized as a rates of ratio, prevalence rate, incident rate and death rate. It also concerns with the health related states or events in the community, example health needs, demands, activities, healthcare utilization. The next one is the distribution of disease. Refers to the sequences, places of occurrence and person affected, that is time, place and person. This is very important in descriptive epidemiology. Then determinants of the disease like physical, biological and behavioral factors that can influence the health. Terminologies like what is variate? Variate means any piece of information referring to the patient or his disease. Variates are two types, namely the discrete and continuous. The first one is discrete, which means present or absent. Only two options, present or absent. That is dichotomous. Continuous means it will be like there is no fraction here. It will be continuous. Like BP, it may be 120 by 80 or sometime 130 by 8 depending on the age and the person. Then serum cholesterol, your height. Some people will have 172 centimeter, some will be 184, like that. It will be a continuous number. There won't be a fraction. But in the discrete, there will be a fraction in the continuous, but in the discrete, there will be all or none, like present or absent. Circumstances. Any factor in the environment that might be suspected of causing disease. For example, respiratory problem, which may be caused from the air pollution. Coming to the tools of measurement. Rate, ratio, proportion. This is very important. Coming to the rate. Rate is the frequency of disease or characteristics expressed per unit of size of the population or groups in which it is observed. A rate measures the occurrence of some particular event, that is, development of disease or occurrence of death, in the population during a given time period. It is the statement of the risk of developing a condition. Coming to the rates, rate comprises of the following elements like the numerator, the denominator, and the time specification and a multiplier. The time dimension is usually calendar year. The rate is expressed per thousand or some other round figures, selected according to the convenience or convection to avoid fractions. Concepts of numerator and denominator. Coming to the numerator, numerator refers to the number of times an event, for example, sickness, birth, death, has occurred in the population during a specified time period. The numerator is the component of denominator in calculating the rate, but not in the ratio. This is the major difference. If you are calculating the rate, then the numerator is the component of denominator. But when you are calculating the ratio, this is not the case. Like numerator may not be the component of denominator. Coming to the denominator, numerator has a little meaning unless it is related to a denominator. The epidemiologist has to choose an appropriate denominator while calculating the rate. Rate means it should have both numerator and denominator, and it should be related one. I will explain you like how it should be related. Coming to the related to the population, like mid-year population, population at risk, percent time, percent distance, subgroups of the population. Then related to the total events, for example, infant mortality rate, case fatality rate, or number of accidents per 1,000 vehicles. Various categories of rates, for example, crude rates. This is the actual observed rates such as birth rate and death rates, also known as an unstandardized rates. That means there is no standard. Coming to the specific rates, these are actual observed rates due to specific causes, example tuberculosis, are occurring in specific groups, example age, gender, or during specific time like annual, monthly, or weekly. Then standardized rates. These are obtained by direct or indirect method of standardization or adjustment. Example age, gender, standardized rates. For example, death, number of death in 1 year into 1,000 divided by mid-year population. So then here, to calculate the death rate, we have the numerator, number of death in 1 year. Then the denominator is mid-year population. The multiplier is 1,000. So coming to the crude rates, if I tell the death rate of Malaysia is 60%, this is nothing but the crude method of telling anything. I am not specifying which age group or which gender or which location, a particular location. I am telling the whole. That means I am telling the crude values. Coming to specific, if I tell the caries prevalence is 60% in age group of 5 school going children, so I am specifying the age group. That is nothing but specific rates. Coming to standardized rates, that means I am comparing with some standard one, or I am adjusting that one. For example, number of death in 1 year into 1,000 divided by mid-year population. So I am standardizing to like per 1,000 how many people are dying. This is the example of risk rate. In the study of diabetics, 100 of the 189 diabetic men died during 13-year follow-up period. calculate the risk of death of this man, that is the death rate. In the numerator, it will be like 100 death among the diabetic men. In the denominator, there will be like 189 diabetic men. So the risk is 100 by 189, that is numerator 100, denominator 189, into the multiplier, that is 100, it's 52.9. So the risk of the death or the risk rate is 52.9%. Coming to the ratio. Ratio expresses relationship in size between two random quantities. The numerator is not the component of denominator. The numerator and denominator may involve an interval of time or may be instantaneous in time. Broadly, ratio is the result of dividing one quantity by another and is expressed as x is to y or x by y. Example, number of children with scabies at certain time, number of children with malnutrition at certain time. The second example for the ratio, deliveries infant mortality rate in 2001 was 10.7 per 1000 live birth. In New Hampshire's infant mortality rate in 2001 was 3.8 per 1000 live birth. Then calculate the ratio of infant mortality rate in Delaware to that in the New Hampshire. So the numerator will be Delaware's, that is 10.7, divided by the denominator, that is New Hampshire's, that is 3.8, into 1. So it will give like 2.8:1. So in the conclusion, you can write Delaware's infant mortality rate was 2.8 times as high as New Hampshire infant mortality rate in 2001. Coming to the proportion, a proportion is a ratio which indicates the relation in magnitude of a part of whole. The numerator is always included in the denominator. Proportion is usually expressed as a percentage. So here the multiplier is always 100. So example, number of children with scabies at certain time divided by total number of children in the village at the same time into 100. This is example of calculating proportion. Calculate the proportion of men in NHANS follow-up study who were diabetics. For example, numerator 189 diabetic men, denominator the total of men is around 3340. The proportion is like the numerator, the 189, the denominator, the total persons. So it's like 5.66% among the men were affected with diabetes. So these are some of the examples of this. So you have to read some of the articles, and your next assignment is to write 2 examples for rate, ratio and proportions. Thank you.